interesting technology that has existed for a while, but that is becoming a de facto new standard of remote procedure calls. Give it up for Stefan Meshkat.
Yeah, hi. Nice to be here again. We start right away talking about json RPC. A little bit motivation to start with. Ajax is very well known, I suppose. So that's a new way of building web applications. And the essential property of the Ajax architecture for web applications is to move application logic from the web server to the web client, that is to the browser. So you push program code to the browser and the application logic actually executes inside the browser on the client side of the application. Another buzzword, which is nevertheless very appealing, is service-oriented architecture. And that's another architectural trend that essentially moves application logic out of the application altogether. So instead of implementing services in libraries or in components that eventually have to be deployed on the same computer as the application runs on, functionality is just factored out of the application altogether as a service that is made available on the network somewhere, be it a local network or even nowadays, be it the public internet. And if an application wants to use that functionality, it doesn't have to link with a library that implements this functionality or load data from the local disk in some way, but it just talks to the service over the network. So both taken together, moving application logic from the server to the client and factoring out application logic of the application altogether and deploying it somewhere in the network yields as a sum the suspicion that it would be nice if the application as it runs in your web browser could talk to some remote services directly. So, but there's a catch, and that is cross-site scripting security. So, and this, if applied, or if the techniques that are usually applied in Ajax applications are applied naively, then this just doesn't work. An Ajax application or the browser, the part of the Ajax application that runs into a browser, just can't talk liberally all over the network. At least not using the naive techniques of XML HTTP request and what it is. So before we go into details of that, let me just bring some definitions. So the policy that governs this cross-site scripting restriction of web applications is the so-called same origin policy. And the same origin policy stipulates that code, that is for Ajax JavaScript code that runs inside an HTML page, can access content only from the same origin as this HTML page. And same origin, in this case, first of all, is determined by the origin of the HTML. So that will become, that's actually an essential bit of what I'm going to explain in the course of this talk. So the origin of a web page is determined entirely by the origin of the HTML page. So the script that runs into this HTML page can be from somewhere else, that doesn't matter. So, but the script that runs into this HTML page can access data only from the same origin as this HTML page. And the origin, in the case of the HTTP protocol, that is in case of pages that were transferred into the browser using the HTTP protocol, is the HTTP server. And just to reiterate this, the server is determined as the triple of the protocol, that is either HTTP or HTTPS, the host name, that is the name under which the host on which the server runs is identified, and the port number, so the TCP port number on that host. And to make it just a little bit more vague, as is usual when we talk about the internet and the web and all that stuff, this is also usually referred to as a site. So it is not really clearly defined what a site is. So but in the context of cross-site scripting, particularly the site obviously means the server. So just to remember that, originally the web was intended to be a web of hypertext pages, and if you consider the web really a web, that is a network with edges and nodes, then a website would be actually a node in this graph of hypertext networks. That is originally a website, certainly was an HTML page. And nowadays it is only also referred or it is also used to refer to a bunch of related HTML pages. So if somebody sets up a website, that's a bunch of HTML pages that are cross-linked with each other and usually accessible somewhere. So, but in the remainder of this talk, we mean by a site something to which this cross-site scripting policy or security policy of same origin is applied. That is, we mean an HTTP server. And just for completeness, I want to point out that in some situations, this policy also applies to the domain. And to confuse it more, very often a site is interchangeably used with domain as well. But domain in this context refers obviously to the DNS domain name of a host. And so sometimes it's just the host name, and sometimes it is just the remaining parts of the host names, so the host name suffix. So in some ways, or in some special situations, this cross-site scripting restrictions don't apply directly to the host, but can be enlarged or relaxed to apply to the domain in some not very well-defined sense. So just as a reminder, remember this document domain property in the DOM that lets you specify, that lets a document specify that other pages from other hosts in the same domain can access this document as well. And the cookie can specify that it is secure, that is, it can only be accessed or it will only be transmitted for HTTPS requests to the host it is bound to, and it can also specify a domain. Just as a reminder that all this terminology tends to be a little bit confusing. So in the remainder of this talk, we talk about sites and cross-site scripting. So now, what are the cross-site script access restrictions? So script that runs inside an HTML page. And in the next page, or in the next few slides, I explain more on what bearing it has, where the script actually comes from. So now we just consider a script is in an HTML page, independently of where it comes from. Now, what can this script do in terms of cross-site communication? First, a script cannot access data or content from other sites. So, and particularly it cannot read documents that are loaded in other windows. If the document that this script runs in contains an iframe, and this iframe contains a document that comes from another site, the script cannot access its content, and it is impossible to retrieve content from another site using the XML HTTP request object, and also cookies that are bound to another site. In this case, only the host name of another site or the domain of another site are also not readable for the script in a document. So far, so good. This is actually not very surprising. I mean, that script cannot do this. However, what is kind of surprising if you don't think deeply about it, and even more surprising if you start to think deeply about it, is that script can indeed send requests to other sites. So for instance, it can create an iframe and load a document into it from any other site. It can post a form that has an action that points to another site. It can even create this form element dynamically and then submit it dynamically even though it points to another site. And it can load or create HTML elements that have external content. So for instance, the IMG element. So you can create an IMG element and load an image from any URL in the internet into it. But the restriction in all these cases is that whatever comes back as a response is not accessible to the script. That is, the script can send a request or take an action that results in sending an HTTP request to another site, but it can't read the response that comes back. Just for your entertainment, I put this remark here in parentheses, almost not. So in the only case I can actually think of that a script can legally read part of the response that it sends as a request, or to a request that it sends to another site, is if it creates an image element, and this image element is loaded from another site, then the size of the image is exposed in the DOM interface of this image element. So, and this size is accessible to the script even if the image comes from another site. So this is, given what I'm going to say in the remainder of this talk, not very useful actually, because there are more efficient way to establish a cross-site communication channel. But nevertheless, that's a cross-site communication channel where script in one page is actually allowed to read data that come into the page from another site, and everything else is forbidden. So now the reason for this. For this set of restrictions. So the first thing, why all these things are allowed that scripts can do, is because that's the original semantics or the original range of functionality of static web pages, that is of static HTML. So the original idea of the web was to create a worldwide web of hypertext pages, and obviously you want to have worldwide links, that is links that point from one side to the other, and forms are just a very convoluted form of links, so you want to also have forms that submit things to other or submit requests to other sites. And it would be very, very disadvantageous or actually impossible to restrict that semantics just by adding or improving or augmenting the functionality of a page by also allowing script to execute inside it. So that's why these things are not restricted. The other thing is this coexists very well with domain-bound authorization. So usually, if you authorize some actions or some activities in the web, you do that based on domains. So this is either if you do HTTP basic authentication in order to bind authorization to it, or if you do cookie-based authorization, that is, if you put an authorization token to allow certain actions into a cookie. And everything is basically aligned with the domain. And so usually the assumption is that the authorization boundaries somehow align with domains in the URL. So that's very vague, of course. And the last assumption is that somehow why all these things are these are forbidden and the others are allowed, is that there's nothing to hide from script in the same page. That is, if a script executes inside a page, the assumption is that nothing is worthwhile to be hidden from that page. So if a page allows a script inside it, then everything that is in the page should not be hidden from the script. And this is actually that's actually the only really dangerous assumption in this whole set of assumptions. And this, by the way, is why script injection attacks or cross-site scripting attacks to websites are effective. So these two set of restrictions and allowances collude to make it possible that a script that ends up to be inside a page can not only access all the data that are in a page, but they actually can send this data out of the page to somewhere else. So script can see everything in a page, and it can make requests that transmits information to any places in the web. So, and this is exactly what happens if you have a cross-site scripting attack that, for instance, steals an authorization token that is stored inside a cookie, or something like this. So, and if it were not for cross-site scripting attacks or script injection attacks, this set of requirements or allowances would actually be sane. Okay. Now the other side of the same thing. I mentioned that I'm going to talk about, or I mentioned that it doesn't matter where the script that runs in the page comes from. So in particularly, in any HTML page can load script from anywhere. So the script just runs in the HTML page and is governed by the cross-site scripting access restrictions of that HTML page, determined by the origin of the HTML and completely independent of the origin of the script itself. So that means script can load it into an HTML page from foreign sites and run in there. And this is actually very similar to all the other external content that an HTML page usually uses. So like image elements or images that are loaded into IMG elements can come from everywhere. CSS style sheets can come from somewhere else. Objects that are embedded into the page using plugins can come from elsewhere. So this is just at the HTML level another form of replaced content. So just an element with an external reference that pulls some content into the page when the page is loaded. However, it does obviously way more than the usual IMG element would do. The other noteworthy observation is that the script elements that pull in script from other websites can not only be loaded or be part of the HTML page when it is loaded, but they can also be created dynamically by the script when it runs in the HTML page. So, and this is actually very important for the technique I'm going to describe, but it still sounds scary, particularly since we are aware that cross-site scripting, because of the restriction and non-restrictions that script is subject to, because it opens up ways or vectors of attacks on web applications. So now, and also I explained that usually script that runs in a page cannot access content from another site or from another page. However, script that runs in a page can dynamically create script elements in that page that come from another host, and yet these script elements become, or the content of the script elements becomes fully available to the script that runs already in this page. So and this is already very different from IMG elements or from iframes, let's say. So if you create dynamically an iframe and load a document in it from another site, then the content of this iframe is not accessible to the script. However, if you create a script element dynamically and load a script from another page or from another site into the page, then the content of the script element becomes in a certain way accessible to this page and accessible to the script in this page. So, and this is in contrast to the policy that governs other forms of content that are pulled into the page. Sounds very scary. So the question is, why isn't that forbidden? So, and why was it designed so differently at the time when it was designed from the policy that governs access to iframe content, for instance? And the reasoning behind it seems to be that script usually contains no data, or script elements contain no data, only code. And code is usually not as sensitive as data. So for instance, if you think of one kind of sensitivity of data that you want to protect using these cross-site scripting restrictions is personalized data. So if a page contains personalized information, and you don't want other pages to spy on this personalized content of this information. And this is also the main target of cross-site scripting attacks, actually, to glean information, personalized data from a page. So, and usually, script only contains code, and code is usually not personalized, except in web pages or in web applications with very bad design. So that's not that unusual, actually. But in theory, code is not personalized and hence not sensitive. The other thing is, when a script element loads script from another site, the content of that script is not directly accessible to the page. It is only that the script that is loaded into this page is executed while it is loaded, and that's it. So there is nothing, no way, or no direct way at least, and no systematic way to access the content of the script as text or something. It's just evaluated as script, and usually what it brings in are additional function definitions, and these functions then can be executed as well. But there's no way to directly pull in the script text into the page. And moreover, script elements only load script into the page and nothing else. So if you create a script element and load, say, an HTML page into this, or well, an HTML page into the script element, that just results in a syntax error when this HTML page is executed as script, and nothing will happen actually. So the content of this HTML page will not become available to the page. So so far, so good. So that's the framework within which we want to implement a way for web pages to talk to web services on foreign websites directly. So before I come to that, I just want to point out another useful ramification of this environment. So this is cross-site libraries. So since a script element or the content of a script element can come from arbitrary pages or from arbitrary points in the web, every web application can just include a script element that provides a certain set of or that loads a script that provides a certain set of functionality inside every HTML page. So this is kind of a dynamic linking for at least the client side of web applications. So a web application can use centrally deployed libraries in all its web application, in all its HTML pages. So that's already a very useful thing. So for instance, the Google Maps API, which is probably known, does exactly this. So the Google Maps API provides a way to embed an interactive map with the full content of the whole Earth and all that zoom in, zoom out functionality into any HTML page. So and the way it does it is just to include a script from a certain well-known URL into any HTML page in which you want to use this functionality. So you just do this, and then this whole set of functionality is available to a web page. So now the more interesting thing are cross-site services. That is the actual subject of this talk. So in there, it is a little bit more convoluted. What has to happen? So the central idea is to dynamically create a script element and have that script element point to a URL and to load from that URL data. So because that's what web services are about. You send a request to a certain URL and you get back a response that encodes some data that answer your request. So the way is to encode the request in the URL or in a certain URL. And from this URL, you get back data in some form, and these data answer your request, basically. And these data are loaded into a script element. So, and this is what happens here. And now I just explained that the content of a script element is not available to a page that loads the script element or that creates the script element, but the content of the script element is just executed, so, or evaluated. So, and now, from a service, we want to get back data. And data are just an expression. So obviously, this is a valid, or just an expression, is a valid JavaScript program in this way. Or you can also send back XML, for instance, encoded in a JavaScript string. But these data are just evaluated, and then they are gone. So if you just load a data structure into a script element, nothing happens effectively. So they're just evaluated, the data structure is created, but nothing happens with it, and it is just evaporates. So, and therefore, we need something to actually propagate these data to where they belong. And this is what happens with cross-site services. So the thing is, an application that wants to use a cross-site service first creates a callback function. So in this callback function is meant to receive the data that are the result of the service invocation as an argument, also as an argument. So in this callback function is registered under a well-known name somewhere in the page. So then this request is, or the script element is created. The request is encoded in the URL. The URL is assigned to the source attribute of the script element and hence sent to the server. And the server sends back the data, obviously, as a JavaScript data structure, but around this data structure is a function invocation of the function that is registered as a callback for this service request. So when that comes back and is evaluated, then this function is actually invoked with the response data passed as an argument. So in the following few slides, I will give an example that actually makes this very clear. But that's the idea of cross-site service requests. So the essential idea is not to receive back only data, but to embed these data into a function invocation of a function whose name was agreed upon before the request is sent. Okay, and when this happens, when the script element loads, then this function is called and the callback is just invoked. And if you like words as much as I do, then you notice that this is exactly what the first A in Ajax stands for. This whole thing is asynchronous. That is, you invoke a service request or you create a service request, then this service request is actually processed and eventually comes back to you, but not in the form of a return value from a function, but actually in the form of an invocation of a callback function that you yourself provide to your service request. Okay, so far for the theory. So now we get to something interesting. Before we get to the example, just let me summarize, or just let me point out that the data structure, of course, that is transferred in this way is usually a so-called JSON data structure. JSON means JavaScript object notation. But it actually doesn't really matter. The point is, this data structure is encoded as JavaScript, and it will also, when it comes back, treat it as JavaScript. And the point is, you have a callback function, and you pass the return data as argument to this callback function. And these arguments don't have to be a single object, which would be stipulated for JSON. So JSON is just a single JavaScript object with properties that hierarchically can be other JavaScript objects or arrays. But any JavaScript expression works here because we are completely inside the JavaScript realm. And the other thing that is noteworthy is that cross-site services and cross-site libraries often complement each other. So usually a web service is defined at the interface level. So that is at on the wire effectively. So it is defined what URL to send somewhere or what request to send somewhere specified as a way of building a URL and what data to receive back specified in terms of a data structure that you expect. However, very often it is convenient to think of a service as a programming interface, so an API. And this can be very easily achieved by combining a web service with a cross-site library or a library that effectively implements the wire protocol of the web service and exposes it as an API, that is as an object that has methods which you can call on this object. And other functionality that is cross-site library that complements such a cross-site service provides is, for instance, caching. So this is also if your service is likely to, or if it is likely that you want to repeatedly invoke the same operations of your service with the same data, and your service is actually idempotent, that is, stateless. So that is for the same request, you always get the same response. Then it is very worthwhile to, for instance, provide caching on the client side, so as to provide faster responses and so on. Okay, now we start with a little example. And in this example, I provide, or I demonstrate a complete implementation of such a client-side service, or of the client side of such a web service implementation. And the example I would like to discuss is the geocoding service in the Google Maps API. So I mentioned this Google Maps API that allows you to embed a map into a page. And geocoding is to figure out at which place on Earth a given name belongs to. So a name can be a name of a place, it can be a street address, a name of a city, and so on. So this geocoding service, or this Google Maps API, since earlier this year provides also a geocoding service. That is, in the Google Maps API, you can instantiate an object, So how you do it is seen here. So you can, in order to create a map, you instantiate this gmap2 object, and in order to use this geocoding service, you instantiate this client geocoder object. And on this client geocoder object, you invoke, or one way to use it is to invoke this method, in this case called getLatLong, and you pass the name of a place that you want to geocode, or generally a name that you want to geocode, and as I explained earlier, a function that expects to receive the result of this service invocation as an argument. So this is a function, and you expect to receive a point on Earth that is a lat-long, so a pair of geographical coordinates. So, and with this lat-long, when this function is, or this function will eventually be invoked when the service request receives a response, and with this result you can do something. So, for instance, set the map that you've just created to show this particular place on Earth. So that's how it looks at the API level. And this is exactly the case that I mentioned earlier. So there is a protocol defined on the wire that exposes this service, but on the client side, the service is wrapped into an API, so into an object that encapsulates this functionality. So, and what happens on the wire is shown in this slide. Actually, before we look at what happens on the wire, I just for completeness, to show you how this looks like. So I just give a very brief demo. So this is such an HTML page that contains a map, and in this HTML page, you see exactly what you've seen before. So this is here, the map is created, here the geocoder is created, and eventually, so if I hit this submit button of this form, if we have such a geocoder, then we just pass this address that is taken from the form inside this HTML page and pass to this geocoder, and eventually with this with the point that is returned from the geocoder, we set the center of this map. And then as a special case, the geocoding can obviously fail if you pass an arbitrary string, and in that case, this argument is null, and then in that case, we display an alert. So this is what happens, and if I do this, so I'd say, for instance, Berlin here, then Berlin is shown on the map. So, and okay, and what you've just seen happened, or what happened on the wire while we looked at this thing is exactly this. So this is basically the other end of the implementation on the client side. So this was the client or the API level, and this is the wire end of the whole thing. So what was sent to the Google server that implements this geocoding functionality is this URL. So this first the host name, obviously, that's maps.google.com. The service name is /maps/geo. Then we encode the actually request data in this queue URL parameter. We also request that the output be JSON. And it's actually not quite exact that the output is JSON, because the output is JSON with this padding around it. That is this function invocation that will pass on the response data to our application. And this is strictly speaking not JSON. It is JSON surrounded by something else. And this something else is actually also specified in the URL. And this is in this callback parameter. So and the function that will be called is called cbstore.cb1. And we also have to pass a developer or an API key, but this is a technicality. But the essential thing is, this is the request data, and this is the callback to which to direct the response. So what comes back is indeed the response. So this is first a data structure that contains the result of this response. So it first echoes the original request. Then we get a status code which is 200, which just means okay. And then the data that are passed back is as an HTML, or a data structure that is called a place mark, which contains a name for a place and a point on Earth for this place. So this point on Earth is specified as coordinates, which are geographical coordinates in longitude and latitude. And because we do this also for 3D applications, so just remember we specify output JSON, and the alternative to output JSON would be output equals KML, which is this XML data format that allows you to annotate Google Earth, so this 3D visualization of the planet Earth. So, and in a 3D environment, it makes sense to also have an altitude, and that's why these coordinates are given as a triple. So, and these coordinates are obviously, well, longitude and latitude here. So, and this is the center point somewhere of Berlin. Obviously, the returned data could be more elaborate, and in practice actually are more elaborate. So for instance, we also give indications of how big this place actually is. So you might notice that it doesn't really make sense to locate Berlin at these exact coordinates. So it's just the center point of Berlin, and it is also worthwhile to have an indication of how big this thing actually is. And in reality, this response also contains data about that. And if the address is actually a street address, then the response contains also data how the street address is decomposed into certain parts, like a street name and a house number and so on. But anyway, so that's what happens. So what I'm going to explain now is what happens in between. That is what happens between the API level and the wire level. So that is all this, where all this goes on what I introduced earlier, that is the creation of the dynamic creation of a script element, the construction of a URL, the registration of a callback, and so on. So this starts here. And before we start, we need a few global variables and abbreviations. And for the sake of this example, we disregard naming requirements that are usually imposed by larger applications. So for instance, it is kind of very adventurous to have a global variable called base. So, and we just have it here for simplicity, but in a real application, of course, you have to encapsulate that in a namespace or invent a prefix name or something. The same for counter. Obviously, you don't want to have a global variable in the first place at all, and particularly not a global variable that is called counter. So, but this is a counter that we will use eventually, and we have this this object, that's a JavaScript object literal called cbStore, which stores the callback functions for our service requests. And we make one little abbreviation. We will use the built-in function encode URI component. And in order to fit this example on 3 slides, which I'm going to do, I abbreviate this function as just encode. So we keep in mind that we mean encode URI component by this. Okay, and this base is the base of the URL to which we send the request. That is the URL without the URL parameter part. Okay, now let's look at a function that implements a service request or a general service request using this dynamically created script element. What this function does, it sends a request. Let me see. Yeah, it sends a request to the service that is identified by the global variable base, and to the service it sends a request that is encoded as a name-value pair. So this is a name, and this will be a value, and whatever comes back to this request is supposed to be passed as argument to a function that is also passed as an argument to this function, which is here called callback. So the first thing that this function does, it creates a unique ID for this particular service invocation. And that's a very important step to take, to which I come back later. So generally, everything that is asynchronous has also to deal with concurrency. So if you can invoke functions asynchronously, that is, you invoke them and they will complete only later, you of course can do something in between. In particular, you can invoke the same operation again. So, and that means that 2 invocations of this operation will be pending at the same time, so concurrently. And that's why it is very important to uniquely identify each invocation of this operation, so that when the operation eventually completes, it can complete with the right continuation. So here we have an ID that is very simple. We just call it CB, and then we append the incremented value of the counter. So each time we create such an ID, the counter will be incremented, and the previous value will be appended to this. So the next interesting thing is actually here. And we come back to this previous part a little bit earlier. So here we create this callback function. And we store this callback function right away in this storage of callbacks. So, and we store it under the name of the ID that we just created. So this assigns just a property of name ID, or of the name of the value of this variable ID to this object CB store, which is again a global object, which in a real program, again, it shouldn't be. But apart from being badly designed in terms of having global variables and so on, this example that I'm going to show you is actually fully functional. So it does everything, only you want to guard your namespaces a little bit better. So okay, here we call this callback function that will be invoked by the service or by the response that comes back from our web service. So, and this receives a data structure. So what we do here is three things. The first thing is we cancel a timeout, namely this timeout that is created in the step earlier. And this timeout, that is also a very important thing that we do here, will invoke the callback if we don't get a response from the server. So, and we schedule this timeout to fire 2 seconds after the invocation, which should be enough time for a round trip to the server. And it's actually very important that we do this. So in terms of, or in the case our service is not available, we really do something even in that case. So, but if we get a response from the server, then we don't have to invoke this timeout anymore, and we do it, the first thing we do is we cancel it. Then we call a function that is called cleanup, and the cleanup function is shown on the next slide. So just let me just say here that we remove all the temporary data structures that we created. So, and these are two things. It first removes the callback from the callback store, and it also removes the script element that was used to send this request in the first place. This is also something that you wouldn't think is really necessary, but it actually helps to do it. So that is, if you don't use a data structure anymore, just remove it, just to be clear. So later, if you debug your program and see a data structure that you don't expect to be there, then you know that something is wrong. This is already very good. And in the long term, of course, it also prevents memory leaks. But that's, given that there are so many other sources for memory leaks, it is not really practically important, but it's still also theoretically important. So, and the last thing we do in this internal callback is to actually invoke this callback that was passed to this invocation. So we call back, or we call this callback function. Okay, so I mentioned that for the case that we don't receive a response from the service, we schedule this timeout to also call the callback function. This happens here. So in this timeout, just does mostly the same thing. It also invokes cleanup, that is, it removes the callback and it removes the script element because we don't need it anymore, even if it didn't serve us. And it also invokes the callback, but this time not with data, but with just null. So, and this also establishes a very simple and straightforward status protocol. So if this callback, or if this callback is invoked with data, then the service request was successful, and if it is invoked with null, then the service request was not successful. Okay. So far, so good. So now we actually proceed to send this request. For that purpose, we first create a script element that we do using the usual document object model interface. So we say document create element script. And we insert the script element somewhere on our page. Where we do that is actually not important. So we just append it as a last element to the body, because it is not going to be visible or something, so it doesn't hurt there. And by the way, we are going to remove it later anyway. So here we append this. Now we create the service URL, so and this, or the service request URL. And the service request URL contains of the URL base, of course, and then of this parameter called callback that tells the server what to wrap around the data in order to invoke our callback function. And this is just the name of the callback function. The name of the callback function is called cbstore dot, and then the ID that we use to identify this service invocation. And as a next parameter, we just append this, the name and the value that represents our service invocation. And both of them we encode as URI parameters, so that we are really sure that this arrives at the server as a name-value pair and not something else. So if name or value contain ampersands or equals or something, they will be properly encoded and not mess up our invocation. And that's it. So we just assign this URL to the source attribute of the script element, and that will trigger the request that is actually sent to the server, and eventually will cause the response to be loaded and this callback function to be invoked. So I come back to that slide later because I want to point out a few important things about the coding. But before, I just want to show you this cleanup function. And the cleanup function takes two arguments. So it's the ID of this invocation that we constructed, and it is the DOM node that represents our script element. So, and we do two things with it. So we delete this callback from the CB store object as a first thing, and as a second thing, we just remove this the script from the document body, or the script object again from the document body. Now you see that I don't do it directly here, but I just schedule this using a set timeout to happen, well, very soon. So after 0 milliseconds, which means it is scheduled to happen directly after the current flow of control somehow terminates. So why is this? If you look at what happens here, then, and how we created this callback function, then you will see that this callback function that eventually calls cleanup actually executes while this script element is being loaded. So we load a script element that contains something like cbstore.something in parentheses pass data to it. That is the whole thing, and in particular, the invocation of this cleanup function happens while this script element is being loaded. And now it turns out that some browsers react very ungrateful if a script element tries to remove itself from the document while it is being loaded. And the browser crashes specifically. And the browser specifically is Internet Explorer. So, and therefore, we do instead this, so that as we schedule this removal to happen after the current flow of control has terminated. So, and at that time, the script is fully loaded, everything is there, and the script just defines, no, it doesn't even define a function, it just executes a function invocation. That is, there's nothing left from the script element that is currently being defined and accessible as a global variable and so on. And therefore, it is relatively safe to just remove this or to discard this element. So, and that's what we do there. Okay, the last step is the glue code between this generic service invocation function, send, and the specific service that I've demonstrated at the beginning, which is this getLatLong method of the geocoder, or of this client geocoder object. And here you see what we pass in here is an address and a callback function. And we just pass this on to this generic send function. And I explained earlier that we send the address using the Q query parameter of the URL. So we pass in as the name Q, which is this Q URL parameter, as the value for the address. And as a callback function, we pass in a function that receives this data thing. So, and this data, if it is itself null, or if it is not null, but the status code or the status code is not 200, then we just call this callback that we've received here with null, which means that we didn't get a valid geocoding response for our request, or else we transform this more complicated data structure that we received over the wire into a simpler data structure that we pass on at the API level. So at the API, you remember, at the wire level, we received this complicated data structure that has well, way more information than we are, at least with this method invocation, we are interested in. And at the method invocation, or at the API level, we just receive a single value that represents a geographical coordinate. So with a latitude and a longitude coordinate, and that's all. So, and this is what happens here. So we extract from this complicated or structured or more structured data structure just two values, the latitude and the longitude, and create a new, simpler data structure, such a g-let long object that we then pass as an argument to the callback. And this is it. So that's how such a client-side web service implementation using a dynamic script element works. And I just want to point out a few implementation details. So this is not specific to client-side web services, but it is very important to keep in mind such subtleties when you implement both client-side web services and everything else in the browser side. So the first thing I already pointed out, we design for concurrency. That is, if we have an asynchronous operation, we design for the case, or we design for the case that two invocations of this operation can be pending concurrently. So that's why we have this unique ID per request and deal with that. An alternative, of course, would be to serialize such requests. So that is to not allow another request to the same service while the previous request is still pending. And this is actually a valid approach to this kind of thing, but in general, it is not necessary to do this. And actually, your program keeps much more flexible if you just allow for concurrency and deal with asynchronicity properly. The second thing is, and that's actually a very funny subtlety, it is reentrancy. So if you talk to the DOM, or in general, JavaScript is single-threaded, right? So that is no two threads of execution run at the same time. However, it is reentrant. So if you call a function or a method that goes outside JavaScript, that is particularly if you call a method on the document object model or on objects in your page, this method invocation goes outside JavaScript and back to the browser, and the JavaScript engine is free to schedule other callbacks that are still pending to execute first. So in particularly, if you do something like we do here, we assign to a property or to an attribute of a DOM node. And if this causes some action, so for instance, it causes the retrieval of a script document from some server. So if this completes fast enough, then for instance, this will eventually execute script. So, and the browser is in theory at least free to execute the script first before the flow of control returns to this statement and continues after it. And so you notice that this assignment to the source attribute of the script element is the last thing we do here. So, and this is very deliberate. So I could, with the same semantics or with the same apparent semantics, first assign to the source attribute and then insert this node into the body using document body append child. But what could happen then is that with the assignment of the source attribute, the script is loaded immediately, executes immediately, and eventually will call this cleanup here, which will try to remove this, this node from the DOM. So, but at this time, the node is not yet in the DOM at all, because that's only the next thing I'm going to do. So in principle, we have a race condition there. So, and this is a race condition that doesn't arise due to multi-threading, but it arises due to reentrancy. So, and this is something to watch out very carefully for in programs that run against the DOM. Another thing is robustness. So one thing I already explained, so I avoid suicidal script elements. That is, script elements that remove themselves from the DOM while they are being executed. And another thing, again, in the implementation of this function, is that you notice that I invoke this callback function last. So there's actually no real semantic reason for it. So I could just as well call the callback function first. But the callback function is nothing that I have control over. That is in the sense of I'm as the author of this library. So in principle, this callback function could be wrong. So it could have an error, it could throw an exception. So for instance, I occasionally pass null to this callback function. And if this callback function doesn't expect null and tries to do something with this null that you can't do with null, then it will throw an exception. And then my flow of control would be interrupted here, and the subsequent statements would not be executed. So there are two ways to deal with it. The first way is to catch exceptions, so to do it in a try block. This, however, has the disadvantage that I catch exceptions. So, and sometimes exceptions tell you something, right? Particularly that something is wrong, so they are very useful for debugging. So catching them and suppressing them is not very useful. And instead, the other solution is to just do it last. So even if this callback invocation throws an exception, I don't care because I'm done already. So this is the other thing I wanted to point out. And the last thing is sanity. So I did all this. For instance, I defined this invocation of callback with an error indication when an error actually occurred. So that is, I always callback, and give a proper error indication instead of, if I have an error, just don't do anything. And the other thing is I clean up resources after use. So, and although this technically doesn't really prevent memory leaks, for instance, in any useful sense, it just maintains clarity of design of this implementation. Okay. This is actually it. I'm skipping 2 slides because we have only 3 minutes left. But I'm going to tell you what I'm going to skip. The first thing is just a big caveat and a very interesting outlook. Obviously, if you do this, you can't do this to access data to which you need an access authorization, and this access authorization is actually a cookie, or is stored in a cookie. The thing is, I mentioned earlier at the beginning that script that runs in a page cannot access cookies that come from another page or that come from another origin. So these are data that are not obtainable by script. However, if you just create a script element that points to another site, and for this site there is a cookie registered, then the request that will retrieve the content of the script element will contain the cookie that is registered for the site. So, and now, if this cookie is actually valuable, then this means, so if you send back data to which the access is actually authorized or needs authorization based on this authorization token in a cookie, then this means that any page can access these data, because any page is free to create a script element and point it to that URL. And in order to obtain these data, you need the cookie, but the cookie is sent anyway. So that is, if you want to expose data which to access you need authorization, then you can't base this authorization scheme on cookies, is actually the caveat on the slide, or the essence of the slide. And it's actually very interesting to think about the authorization and trust relationship structure in this case, which is markedly different from a classical or from a normal web application, because there are now, in a normal web application, the user is authorized against the application, and now there are 3 participants in this authorization scheme. So it is the user, and it is the service, and it is the application that uses the service that needs to be authorized in some way. The second thing is, that I'm skipping over here, is obviously it would be nice to have some API standardization for it. Although, if you think about it, it is not that urgent to come up with this, because it is kind of 50 lines of code that allows you to very robustly implement this functionality. But still, 1 single line of code would even be better than 50 lines of code. And therefore, there is some movement to standardize an API for this kind of functionality. So there's a proposal that I hope has failed, which is to build for dynamic script requests an equivalent of what XML HTTP request is for dynamic iframes, which you can use to build AJAX applications without AJAX, basically, and which was already used way before XML HTTP request was both available and also widely known. So, and this JSON request object would essentially behave exactly like an XML HTTP request object, and therefore suffer from exactly the same dissatisfying or unsatisfying properties, let's say. So for instance, it would unnecessarily tie a transport authorization to a data format, so which you actually want to keep separate. So, and it would provide security by coincidence, because it would basically rely on the fact that the response is a valid JSON data format in order to allow this whole thing to go through in the first place. And that's not very, very satisfying. Other promising approaches or proposals propose to modify the HTTP response and to add a HTTP response header field, or to do something like robots.txt does for spiders for JSON requests. And my proposal is just, since it works so well and it works in all browsers and it is really simple to implement, just to go ahead and do what already works and use script. But we can expect something in that direction, probably. Okay, with that I would like to conclude. Again, the thing to take away is probably the real weirdness of restrictions to which cross-site access of script running in HTML pages is subjected. So it can freely write to foreign sites, but it cannot freely read from foreign sites. And this is a very bizarre security model that is very worth keeping in mind when implementing this. So there are a few channels that allow various levels of access and workaround across this policy, and as a consequence we can implement a nifty way to access foreign web servers from inside HTML pages that implement web applications. Yeah, that's it. That's what I wanted to explain. Thank you very much so far for your attention, and questions please.
Hello. I have one question, just a short one.